Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocketman, and today we are talking about solar sails. Hey, Ben, how are you?
Hey Simon, how's it going? Hey fellow Econauts. Yeah, we talked about a couple of different propulsion systems, and today we want to talk about the solar sail.
Yeah, that's already my first question. What is actually a solar sail?
I think we have mentioned it a few times in former episodes, but just so that everybody is on the same page, a solar sail is pretty much as the name describes. It's a sail, like a sail for a sailing boat, but instead of wind, it uses solar energy, photons from the sun to get accelerated. That's the solar sail. So you are sailing the the sunlight. You're sailing the sunlight. It can also be called a photon sail or a light sail. These are equivalent equivalent names for the solar sail.
And what are the advantages of a solar sail?
Well, a solar sail, the advantages is that you don't need to use propellant. So you can build a spacecraft, put a solar sail in front of it, and then you get pushed. And theoretically, you get accelerated indefinitely. I mean, obviously, we have a limit to the speed of light, but that would require that you have constant push from photons.
And we talked about that before the show. It is not possible to fly right at the sun. So you always have to be pushed away.
Correct. So maybe I should explain a little bit more how it works. Pretty much, imagine you have a mirror. Obviously, you want that mirror to be as light as possible because the more mass you have, the harder it is to push. That is also true for the spacecraft you're pushing. Then the sunlight hits that mirror, and the direction of where the sunlight goes determines the direction of the where you get pushed. Although photons have no mass, they carry momentum, and that momentum gets transferred to your sail. And you can change the direction according to which direction you are reflecting the photons back. But obviously now when you think of it, if you have a sun and you have a solar sail and you try to fly towards the sun from any direction, the sun always pushes you away. Right? So you can't different to a sailboat. This is where the analogy more or less stops. In a sailboat, you have the sail with the wind, but you also have the boat in the water. And the water more or less can be used to determine your direction. Therefore, you can also tack into the wind. Whereas in vacuum, we have only the sail. The sail only provides that reflection. So we only have one vector. What we can use is the orbital mechanics. So when we have gravity from celestial bodies, we can use them to also change our direction slightly.
So in theory, we could get with the solar sail to Mars, for example, and then basically get slingshot back from Mars to Earth, and then
Yes,
making
absolutely
sure that
correct.
we are not having the sails basically fully inflated. Is that the
Correct.
correct?
Yeah. So what you would so a way would be, so first of all we have to get to space. You can't launch, photons are not strong enough to push a solar sail plus a spacecraft from our surface, Earth surface, into orbit. Obviously, we need to get there somehow. We have to assemble it there. We have to unfold it there. Also, a solar sail, you need as big of an area as possible, being as light as possible. So that requires to have a very thin film of a reflective material. Usually, these membrane-like sails, they're called mylars because they are very thin foils with a reflective surface. So you have to get that to space first. Once you are in space, you unfold it, place it so that you reflect the light from the sun, and then the sun starts pushing. The lighter the overall spacecraft is, the better the acceleration. Since we will carry some mass, it will take time. So the sun pushes and pushes and pushes and pushes, and you get faster and faster and faster. But that rate of acceleration can be very low. So that means, yes, you get faster, but very slowly faster, if you get my drift. So at some point you will accelerate further. And if, as you just said, if you don't aim directly for Mars, but for the orbit of Mars, you could potentially get into orbit of Mars while you then get the sail back. And then the momentum you have will carry you back to Earth. Plus, let's say we, making the analogy with a sailboat again, we transport something from Earth to Mars. You could now push something out, your cargo, which would accelerate you a bit further. And that should be enough to get back to Earth. Obviously, everything moves it's not just Sun is here, Earth is here, Mars is here. Everything moves in orbit around the Sun as well. So it's quite complicated, but in principle, that's how it works. Yes.
And we talked about the highway in space many, many times. We we can, if we use that analogy again, we can see on the highway are not just cars or not just
Yeah.
motorcycles. There are many different vehicles. There are trucks, there are small trucks, there are big trucks, depending on what kind of cargo they have. They also have a different shape. Some need to be cooled, whatever. But there are all using the same highway to go from A to B. And I can see that this can be an option to, like you said, saving fuel, to have like certain resources transported from A to B. And again, if everything is in motion, as soon as the system is set up, I can imagine that, it gets easier and easier if you have like, you will not have just one vehicle with solar cells. You will have like, many vehicles that are, doing the trip. And then obviously you have to calculate what needs to be transported from, one side.
Yes, exactly. Yeah. So I think the highway is definitely a very good analogy, which is why I'm often using this analogy myself. Not only for establishing the infrastructure in a route, let's say, which you can use often. Obviously, we don't build an asphalt street, right? So it's more conceptually the same, but still, you need to establish the same conceptual things like entry to the highway, exit to the highway, multiple pathways for fast and slow moving vehicles, for large and slow moving and small vehicles, large and small vehicles. So there are lots of similarities in the concept, and I can also assure you we will not have the same congestion, not for the next thousands of years, because there's still, even in orbit, when you see these maps where we have lots of debris flying in our low Earth orbit, there's still kilometers in between those parts. It looks, obviously, when you zoom out and make the Earth as big as a marble, it looks like we're covered in debris. But there's kilometers in between the debris. Otherwise, we couldn't do any space mission anymore. Starting would not work at all because they would just crash in things. But it's 3D. There's lots of space, and we will have the same with a solar sail going probably to Mars. So it's just for cargo. Having said that, the solar sail is still a research and development product. So tests have been done. I think there has been built one, but they are still working on how to actually perfectly unfold it. Because when you have a very thin mylar, and you have to, obviously, as I said, you can't just launch it. You have to pack it. No, a bit like a parachute. You have to pack it in, and then you have to unfold it. But because it's so thin, it can rip. It can have kinks, and we're not there yet. But I think it's worthwhile to investigate and further develop this pathway.
And I think at some point we will have like, some sort of a space dock where we might be able to actually build the vehicle already in space, where, certain issues can be solved right away, because they will be built in a vacuum instead of, on the planet.
And in low gravity.
Yeah, exactly.
Low gravity. That's the bigger issue, actually, I think.
All right. Well, Thank you very much for your time and talking to me about solar cells. Definitely learned a
Always
little
a
bit,
pleasure.
learned a little bit about it. I hope you learned something too. And if you did, don't forget to leave a like and subscribe if you
And
haven't already.
yes, and don't forget to hit the notification bell. And also, let me remind you that we have lots of episodes you can watch, and also the link to the TEDx talk I gave you will find in the last episode.
Yeah. And I hope I see you next time. Have a good one. Bye bye.
Bye.